Okay, so you might want to take out a piece of graph paper so that you can follow along with these questions. We're going to continue finding perimeter and area of different shapes in the coordinate plane. So for question number 1 here, it says, on a piece of graph paper, draw and label Tom in a coordinate plane and label the points. I'm going to hit pause for a minute so that the video stays short. Okay, now the picture is drawn on the graph paper. The first thing says to find the perimeter. So that means the length around the shape. If we look at the picture that was drawn, we're in luck because 2 of the sides are on grid lines, so we can count boxes. So 1, 2, 3, 4, 5, 6. This is 6 boxes. 1, 2, 3, 4, 5. That's 5 boxes. Since T to O is on a diagonal, we have to do a quick distance formula. So we're going to write that down. We're going to plug in our points, and I'm going to, again, hit pause so the video is not long. So if you look, I did do the distance formula. I got radical 61. And again, to find the perimeter of a triangle, we're going to add 3 sides. So in this case, we're going to add 6 plus 5 plus radical 61. Again, we cannot add whole numbers with radicals, so 6 plus 5 is 11, so we write 11 plus radical 61. The second part of this question says find the area. So we have to think back to our area formula. The area of a triangle is 1/2 base times height. In this case, the base is on a grid line, it's 5. The height is also on a grid line. 1/2 times 5 times 6 is 15. So my area here is 15. Now we're going to get a little bit more complicated. So it says on a piece of graph paper, draw and label quadrilateral math, and then find the area. Once again, I'm going to hit pause for a moment. Make sure if you are doing this at home, you do this as neat as you possibly can. Now, if I look at this shape, this quadrilateral, it's an irregular polygon, which means all the sides look different, and it's a little tricky to find the area. If you go back to yesterday's video, I had written down some steps. The first thing that we're going to do here is we are going to box this figure the tightest box possible. So if you notice, the highest point is going to be the highest point on my shape. The lowest point of my box is going to be the lowest coordinate point in my shape. And we're going to create a box. Remember, the neater you are, the easier this will be and the less likely you are to make a mistake. Now, to find the area, in simple terms, I'm going to find the area of the box and then subtract the area of the shapes around it. In this case, I have a triangle here, which I'm going to label 2. Over in this corner, I'm going to knock that out to make 2 triangles and a rectangle. I'm going to call this triangle 3, this triangle 4, and this is, we're going to call this number 5, this little rectangle. So I'm going to find the area of the big box. I'm going to subtract the area of the 4 triangles. And I'm going to subtract the area of the small rectangle. So once again, I'm going to hit pause for a moment so that you don't have to listen to me count boxes. So if I look at the area of the big box, I just counted, and it's 13 by 13. So the entire giant black box has an area of 169 boxes. Now I'm going to find the area of all my little triangles. So I have triangle 1. That area formula is 1/2 base times height. I have triangle 2, same thing, triangle 3, triangle 4, and the little rectangle. Once again, I'm going to hit pause for a moment so that I can do the work and you don't have to listen to me speak. So now if I look at the work that I did, area of triangle 1 is 13 by 2 times 1/2. Remember, I counted here from point here to the end of the box. The area of triangle 2 is 26, 3 is 12, triangle 4 is 4, and the little box is 3. So now to find the area of the red shape, I'm going to do 169 minus, in the calculator, 13 minus 26 minus 12 minus 4 minus 3, and I get 111. So the area of that red quadrilateral is 111. The biggest mistake that kids make when they're doing this, and I'm going to try and highlight this, is right here when you're counting, you have to count to this point that I just made in green. So if you look at triangle number 4, it's very important. That is 8 boxes for the base. Okay, if we look at number 2 or number 3 here, similar concept. So maybe you want to hit pause for a minute and try it on your own. We're going to graph quadrilateral. This is actually not a quadrilateral. This is a polygon house. We're going to label the points, and then we're going to find the area. So you're going to graph it, put the tightest box around it possible, find the area of the giant box that you created, and subtract all the little surrounding triangles. Once again, I'm going to hit pause, and I will show you my work. So now if I look at my picture, polygon house is in red. And then if you look at all the black lines that I drew around it, I turned everything into nice little rectangles and triangles so I can count the grid lines to find the areas. So what I'm going to do is I'm going to find the area of the big box. Then I have here triangle 1. Here is triangle 2. Over here is triangle 3. Here I have triangle 4. Here I have triangle 5. And then I have rectangle number 1, so rectangle 1, rectangle 2, and over here, rectangle 3. So again, I'm going to hit pause for a moment. I'm going to find the area of the giant black box, and then I'm going to subtract all the smaller triangles and the smaller rectangles, and I will be left with the area of that red polygon. So now if I look at my work, again, it's a lot of writing, it's annoying, and it's counting boxes. So I have my areas of my 5 triangles. So I have 6, 49.5, 9, 10, 7. I also have the areas of the 3 boxes, 18, 28, that should have said, and 6. So now again, to find the area of the red shape, what I'm going to do is I'm going to take the entire shape, 234, and I'm going to subtract all of these areas which I just found by counting boxes. So again, hang on 1 second so I can write it down and use my calculator. So now if I look at this, if I subtract, I do get 100.5 or 100.5, however you want to write it. Once again, the most important thing here, and I'm going to try to zoom in, when you're counting your boxes, you need to make sure that you are counting from this point here all the way up to this point here. Even though in this little area it looks kind of squished, there is a tiny little piece of area there, and if my picture was a little bit neater, you would see it. So again, not overly difficult. The biggest mistake kids make is counting the boxes. So again, it's very important that when you do this, you do show all of your work, because on the Regents, we can give you credit if you show all of this, and let's say one of those is wrong, we know you understand the concept. Okay, moving right along. We've got a quadrilateral dogs. It says label the points and find the area. So once again, I'm going to hit pause for a moment. So again, looking at my picture, it's an irregular polygon. So in order to find the area, what we're going to do is make the tightest box possible around the figure. The neater you are, the easier it will be to count your boxes. And then again, we're going to break up the distance between the red and the black box into triangles and rectangles. So in this case, I'm going to drop a line there and drop a line here. So now I have triangle 1, triangle 2, triangle 3, triangle 4, and I have box, we'll call that box 5. So once again, I'm going to find the area of the giant black box. I'm going to subtract those 5 shapes. and that will leave me the area of the red polygon. So if I do all my math, I get the area of the giant box to be 238, so that's 238. I'm going to subtract the area of the 4 triangles plus the 1 rectangle. So we're going to do 238 minus 18 minus 35 minus 39 minus 10 minus 24. If you're doing this on your own, please make sure that you check when you're counting your boxes, because the biggest mistake kids make is that they count wrong. You always want to make sure you go to the actual point. You should have gotten 112. If you tried it on your own and you got something different, please check here. The reason that I'm showing all of my work is those are the boxes, the number of boxes you should have gotten for each shape. We're going to try one more, and then we will practice this again in class. So this one says find the area of hexagon linear. So again, first thing we want to do is graph it and box it. So once again, I will hit pause so that you don't have to watch me counting boxes. Okay, if we look at this one, when I created my box, I noticed that side LR right here is on a grid line from L to R. So I only had to make the box going to the right side. Then it got a little tricky because, again, when you're breaking up the area between the box that you created and the red shape, you want to make sure that you're drawing on grid lines and creating triangles and rectangles. So I had to think about it a little bit, and we did break it up into 5 different triangles and 2 rectangles, which I did try to label to the best of my ability for you to see. Again, I'm going to show all of my work. I showed that I found the area of the box. I showed the areas of all the little pieces that I wanted to subtract. This way, if I get something incorrect, if my work is shown, I can get most of the credit. Again, I'm going to zoom in for a minute because the biggest place where students tend to make mistakes, if you look over here, and let me get my green pen, right here, if you're counting here, you have to go to the actual coordinates. So this counts as a box, this counts as a box. Even though it looks like the red line and the black line are colliding, they're not. There is a tiny little bit of space right in there, and we have to account for that using the formula. So again, we want to make sure that we box it in the tightest box possible. We want to show all of the work so that if by chance we count something wrong, we still can get almost all the credit. Please make sure you write down any questions that you might have and either email me or ask me next time you see me.